and this is the cause of standing waves. So you people are knowing because you have gone through that. Okay, the most common cause of standing waves, again I'm just going to repeat a few line. Okay, it is the phenomena of resonance, right? So this all we have seen it, so I'm not going to move it further, you know that. Okay, so here is the last the things which you people have to keep in mind. If you see this, every activity which we have seen, which we have covered in our lectures, all such things are depending on the frequency. Okay, it depends on the frequency of incident light which you supply to the system. Okay, so if the frequency is large, accordingly you will see some different energy level. Okay, the energy level spacing will be large. If high frequency, you are going to use high frequency, that means high amount of energy. So basically all such activity will be depending on the frequency itself. So this is the important part. You have to keep in mind that all such activities in the laser are mainly frequency dependence. Okay, move it. These are the references we are going to use continuously in our lectures. Okay, and let me go through this. Yeah, so now at this moment it is clear from the previous lectures also that the two level system cannot be useful to generate the laser light, because we have seen with some formula that even though you increase the temperature, okay, or even though you increase the energy level difference to minimum level, then also the number of particles in the upper level cannot be larger compared to the lower level. Okay, so again I am repeating, those who are new, okay, as well as old also. For generating a laser light, the requirement is the upper level number of particles have in large number compared to the lower level particle. Okay, and that process by which you achieve this criteria, that process we known as a population inversion. Okay, so this is one criteria for generating the laser. And second is the number of stimulated emissions has to be more. These two criteria are there for generating the laser light. So if I talk about the two level system, which is very basic system, so in the two level system I am not able to generate laser light because the number of particles cannot be larger in the upper level compared to the ground level. What maximum is possible is they can equal with each other, but that again is a hypothetical case, because in that case you need to keep the temperature as maximum as possible, like infinite, or you need to make the energy level difference almost zero. Okay, so in practical that is also very difficult, but one can consider that. Even though if you consider theoretically or ideal case, then whatever the practical case may be, both can be equal, not more than that. So that's how this two level system failed to generate laser light. So if two level system is failed to generate laser light, then why don't we go for the three level system, or maybe the four level system? Okay, so here you look at, as I said here also, that it is not possible to achieve steady state. This steady state, that means the number of particles does not change with respect to the time. Okay, so the number of particles which are there in the energy state, that does not depend with the time, so that state we are knowing as a steady state. Okay, so to achieve steady state population inversion in a two level system, it is not possible, right? So to obtain this, we need to go for this three level and four level system. But to understand the three level, four level, again there is a way we need to look it out, because whatever we have seen in the earlier, that is just a glimpse. Okay, how, on what basis we are saying the two level is not able to generate laser light. Now we'll see the full mathematical proof for the two level system. So let me go through the content one by one. Now this is important, rate equations. Okay, so why it is important? See, whatever we do in the physics, okay, you must understand the importance of each and every aspect. So the next quantity which is very important to understand the laser physics is the rate equations. So you see I have written down the requirement of rate part. Okay, so let me annotate it so that you people may be clearly following. So look at the first part. These are the purpose of using rate equations. First requirement or the purpose is to define the rate at which the population is nothing but basically the number of atoms or the particles which are there in different energy levels. So to define the rate at which, and remember one thing, when I say rate, that means I am talking about number of particles per unit time. Okay, keep in mind, whenever I say rate, that means I am talking about the number of particles or number of atoms per unit time. So to define the rate at which populations, that means number of atoms of various energy levels, changes under the action of pump, okay, and in the presence of laser radiation. So suppose whatever the amount of pump is the energy which you supply, so whatever the amount of energy you are supplying through the pumping mechanism, how their number of particles are changing with respect to that. Okay, so that all things can be decided by the rate. So this is first objective of writing such rates. Second objective, you see, the rate equations approach provides a convenient means by studying the time dependence. So as I said, rate is nothing but the time dependency of the number of particles present in different levels. So it also important to understand how the number of particles, okay, are changing with respect to the time. So it's a time dependence of the populations, yani same, of various levels in the presence of radiation or frequencies. So you see again the same thing, that means h nu I am talking. Okay, why I'm saying frequencies, because that nu can be of either visible light or be of UV also. So that is why whenever, if you remember in the first lecture, I have said H nu photon we are going to strike on the system. I never said it is the visible light photon. It is a photon, but you cannot decide that it is light photon or infrared provided until you know the frequency of the source. Okay, so it all depends on the frequency. Then only you can consider as an infrared photon or UV photon something. And that is why I have said presence of radiation of frequencies. So that all depends corresponding to the different transitions of atom. Okay, so जितना आप energy supply करोगे, frequency supply करोगे, accordingly they will change. And how they are changing with respect to time, so they are able to find out with the help of rate equations. Coming to the third, it also gives the steady state population difference between, just 1 minute. Yeah, so it also gives the steady state population difference between the actual levels involved in the laser transitions. So whatever the, see, just one more thing you keep in mind, that your laser light or laser signal is coming out between two energy levels only. Okay, even though it is 3 level or 4 level system, but this light will be generated from any two levels. Okay, so which are the two levels we need to decide. Okay, we need to see in more details what are the results, what are the levels which are involved in generating the laser light. Clear? So because you know that whatever the transition is going to happen, that is happening between two energy levels only, either any you can take it. Okay, we'll discuss that also. So you see steady state, that means again I'm repeating that number of particles does not depend on the time. Okay, so if it does not depend on the time, then how your number of particles are changing, so that's how you can identify with the rate also. Okay, so let me explain the second again, that the rate equations approach provides a convenient means of studying the time dependence. As I said, na, suppose at a particular time you want to know, consider a two level case. Okay, a system which has two atomic levels or two energy states. Fine, now you look at here, if you want to know that at a particular time interval t, what may be the number of particles available in level 1 and available in level 2. So that number you cannot provide it until you know the rates of that particular level. So that is how these rates are important to describe the number of particles at a given time. Okay, that's why I have written it, as a time dependence. Okay, to find out. In the third thing, I'm considering about the time independency part, that means the steady state case. So that also is important to find. Okay, if I want to check it out, like what happens if number of particles does not depend on time, then what happens to the energy level particles. So all such details I'm going to identify, or I'm going to get with the help of rate equations only. Okay, so second number of point we'll discuss with the time dependency part. Okay, third one is with the time independency part. Okay, so both we'll see in the case of rate equations exactly also, but these are the requirements for the purpose of using the rate equations. The last one, you see, it allows one to study whether an inversion of population is achievable in transitions or no. Okay, and if it is possible, then what would be the minimum pumping rate required to maintain the STD population inversion between two levels. Okay, so here is again, this fourth one is very, very important. Okay, because as I said, that two level system cannot be useful to generate laser light. Okay, but on what basis we are saying? Because we have seen that the population inversion is not possible. On that basis we are saying it is not able to generate laser light. But how to check it, whether the inversion happening or no? So that all things can be possible with the help of rate equations only. So that is how this first slide is. Now you see the second one. If suppose it is possible, okay, then you see what would be the minimum pumping. So how much amount of pumping I need to supply so that this inversion can be possible. Have you clear with that? The pumping we are supplying from the external source. So how much amount of pumping I supply so that inversion will happen? When I say population inversion will happen, that means now the number of particles in the upper level has to be more compared to the lower level. If you achieve that case, okay, we are saying it is a case of population inversion. But how we are going to achieve it? Via providing the pumping. So that's why this pumping is very, very important. So I hope all these four part is very clear to you why we are using the rate equations. Okay, so let me go through the next content. Here it is. Let me check it out. Yeah. Okay, now what we are doing is we are going into the mathematical part slowly. Okay, and basically the solid proof on which we are saying that two level system cannot generate the laser light. Okay, so to understand this, again the same thing you have to consider. It's very simple. Okay, let me explain it to you one more time. So how we are writing for such things? So simply you consider an atomic system having two energy levels. Okay, wording can be, I mean, in your own words you can write it, no, not a problem. So consider an atomic system having two energy levels. You can define the energies also, let's say E1 and E2 of level 1 and level 2 respectively. Same way you can define the number of atoms or number of particles also in level 1 and level 2, which is N1 and N2 respectively. Remember one thing, whenever you talk the number of particles, number of atoms, always we are considering in terms of per unit volume only. Okay, and now see again same thing, that same radiation at frequency omega with energy density u nu will be incident on the system, just like we did in the earlier case. Okay, now this is the rate of absorption we are considering, but this is nothing but the same thing in the earlier one. The earlier, let me write it over here. Earlier what we have written is this is equivalent with B12 N1 energy density. Okay, so what they have considered is this N1 they are keeping as it is, and then this B12 and this factor B12 u nu they are representing with W12. Okay, so it is same from the earlier process which we have discussed, the rate of absorption, that is B12 N1 into energy density. But what we have considered is this energy density and this B12 product we have written down as W12. Okay, N1 is there as it is again. Okay, so no need to confuse, same thing we are using. The only thing is we are now reducing the number of parameters so that mathematically when I solve this particular problem, I may get the flexibility to find out the answer very easily. Otherwise, if I use large number of terms, components, then my mathematics part is getting complex. So that is why I just merge this B12 into energy density with W12. Okay. And what is W12? It is nothing but the same probability as we have discussed earlier. So absorption probability will be W12, which is the product of B12 and energy density. Similarly, you can write the rate of stimulated emission process also. And for that, if you remember, we have considered, let me write the formula B21, okay, energy density, okay, and then N2. Correct? This was the one which we have used for the stimulated emission process. Now this again, B12 into energy density, you can replace with W21. That's what we have written over here, W21. Okay. Now again, if you remember from the Einstein coefficient formula, this B12 and B21 are equal. Okay, energy density is the same. You say it is a constant over here, it is not varying right now. Both are having the energy density term in the formula. Only thing is this B12 and B21, and we know that both are equal. So what you can do is similarly, so this W12 and W21 is also going to be equal, and that is why if you see over here, sorry, so that is why if you see over here, I have written as W12 equal to W21. Okay, so that formula W21N2 equal to W12N2 I can write. There is no harm in that. So I hope now you are clear with this, how I can write this, because B1 equal to B21, and same way this W21 equal to W12 you can write. Okay, so this is how you can write that part. Again, I'm repeating, N1 is the number of particles in level 1, N2 is the number of particles in level 2, W12 or W21 is the corresponding probabilities. Okay, if W12 is there, then for the absorbing probability, W21 for the emission probability. Okay, both are the stimulated process only. Now you go further. Okay, so let me move it further. And on the right hand side, you can see that that setup also, right? I have provided you that diagram for your understanding purpose, so that you can easily see how this level system is working. Okay, now let me move it forward. Now this time you have to write for the third process, that is the spontaneous transition process. Okay, and for the spontaneous transitions, if you remember, let me write down the terms also. That rate is depending on N2. If you remember correctly, N2, and if you remove the proportionality sign, that comes out to be A21 N2. Okay, so A21 N2 is this is the term for the spontaneous emission process, because N2 is the number of particle, A21 is the probability again happening from 2 to 1 for that process. Clear? Now remember one thing, when you are going into a more depth, then you need to consider the radiative part and the non-radiative part. Okay, so basically in this spontaneous emission process, there are two coefficients are there we are going to use, and collectively we are representing with T21. Okay, what is T21? T21 is basically the sum of A21 plus S21. So this A21 you know already what is A21, but this S21 you don't know. Okay, so let me explain this, what is A21, what is S21. So whenever the spontaneous emission process is going to happen, please focus on the word, whenever the spontaneous emission process is occurring, okay, there are two probabilities. Either it will emit a radiative process, radiative photon, either it will emit a photon from upper level to lower level, or it may emit a only energy. It can just emit the energy with the surroundings. Okay, so that is how you see I have represented. A21 is corresponding for the radiative part, S21 is corresponding for the non-radiative part. Radiative in the sense, again I am repeating, radiative process or transitions in the sense the process in which photon is going to emit from the process. Non-radiative in the sense there is no photon is going to be emitted by the spontaneous process, only the energy is going to be changed with the surroundings. Okay, so that is how. But remember one thing, the probability of happening the radiative process is very large compared to non-radiative, and that is why in the earlier process we have skipped this one, because this, let me write one more time, this A21 is very large compared to S21. Okay, so because of this reason, because the probability of, yes
Sir, can you clarify non-radiative transition more, like if a photon is not emitted and energy change with surrounding, like I'm not understanding that.
No, what happens in a particular system, so many things are happening, right? See, spontaneous process are happening randomly, we don't have any control, and it is happening by its own. Okay, and kabhi bhi ho sakta hai. But what happens sometimes, if rather than spontaneous only the stimulated is going to be happen, okay, क्योंकि spontaneous उस time पे for example नहीं होता है, या हुआ भी है, तो then what may be the alternate possibilities? It can emit some amount of energy in form of heat. Okay, that can be exchange with the surroundings. So heat के form में अगर आपका energy emit होता है via this process, so that process we are knowing as a non-radiative process. If photon is
Okay.
going to coming out from the spontaneous process, then that is radiative process. But remember, again I said, the probability of happening the radiative process is very very large compared to non-radiative one, and that is the reason we have neglected in the earlier process when we have discussed the earlier lecture. That time we just write A21 into N2 only. But since now we are going into the proper depth, proper content, so we must consider all such factor, and that is why you can write this as a sum of A21 plus S21, and collectively I can represent with T21. Okay, so I hope by this time now you are aware with radiative and non-radiative. Again I am repeating to make it clear: a radiative process where the photon is going to emit via the spontaneous process, non-radiative in the sense only heat is going to be emitted via the spontaneous process. Okay, with this, and that heat can be exchanged with the surroundings, because your system setup energy level will be in the surroundings only. So with the surroundings it can exchange the heat. Another thing is you have to keep in mind the probability, I mean the probability of happening the radiative process is large compared to the non-radiative. Clear? But to discuss the mathematical form over here, we are considering both the factor T21 equal to A21 plus S2. Okay, now coming to this. Yeah, yes,
Yeah.
can you ask? Yes, please ask.
Will equal into N2.
Yeah, please ask.
So it will be E2 into plus.
Yes, yes, yes.
Yes.
So, but you said that in non-radiative transitions, the photons wouldn't be emitted. So why would it depend on the N2? Just like we as E21 into N2 we did, because it depended on the level 2 or maybe particles. But
No,
in
but see,
non-radiative, it isn't
see,
emitting particles.
see
So why
why?
would it be dependent
No,
on?
no. Why we are considering N2? Because your number of particles are involved for the spontaneous process of upper level. Even though that is not going to emit, okay, but that process is happening from the upper level particles. That is why we have considered the factor of N2 over here. So it is always not necessary that when it is going to emit to the lower level, then only you have to consider the number of particles. But if you remember, I told you in the lectures also, earlier lectures, that whichever level is involved in that process, for that number of particles we are writing into here. Okay, so it has no relation with that if it has to emit only. Okay, if that level is involved, that number of particles we need to write that. Clear? Okay, any doubt? Or we are going to write for the rates basically. So for a two level system, all the three process again we have discussed, but in a slightly different manner as per the requirement. Okay, now let me write the rates which you see on the next screen. Here it is. Okay, can you see? First you see the left hand side part. I have written down the rates. Okay, and again I am saying to you people, whenever I talked about rates, that means I am talking about the number of particles with respect to the time. That quantity I am representing as a rate. So here this is, if you see the first one, let me annotate one more time. If you see this one, so this is for the rate. Okay, for level 2, because number of particles of upper levels are involved in this. So this is for level 2. Okay, and this for level 1. So you can consider rate for level 2, rate for level 1. Okay, whenever I say rate, that means I am talking about the number of particles with respect to the time. So that's how I can write it down the left hand side part, but the important is this right hand side part. Okay, now you people maybe like confused, like what has happened, what is written. Even in the book also you can find the similar content. Okay, and it may be difficult for you people to digest, like how they are writing. Somewhere they are using the plus sign, somewhere they use minus sign, this minus here, this plus, and these terms. So it may be difficult, right? So let me make it simple for you people. Okay, So make it clear for you people in a simple words. Okay. Let me take an example. Then only you will be understanding this one. As in the last lecture, we talked about little bit about the business part. Clear? And I hope you people may like that example also. On the similar tone, now this time also we are going for the business part again, but in a slightly different manner. So you people may have heard there is a one subject called account. Okay. It may be possible that you may not have studied for that because you have taken the science subject, but there is a subject called account, basically in the commerce field. Okay. So if you go to the fundamentals of that account part, so what they required is that at the end of the day, your credit must match with the debit part. Okay, whatever the credit you are putting at one side, that has to match with the debit. So जितना आता है जितना जाता है वो सारा रिकॉर्ड आपके पास होना चाहिए. So at the end the difference has to be zero. Clear? So that is how people are doing in the accounting part. So let me take the same example from that accounting field. Okay, and let's consider a case. Suppose I have 100 rupees with me. Okay, and if I give you, let's say, 50 rupees to you. Clear? And you consider that you may have some amount with you or no, it is your choice, but I have 100 rupees and I gave it 250 rupees. Now keep in mind, whatever the things I do or you do, you have to keep a record for that. So suppose if I am giving to you, that means I am losing the amount of rupees 50 from my side. Okay, so from my account I need to keep this amount on debit part, क्योंकि मेरे पास से वो अमाउंट कम हो गया. 50 रुपए मैंने आपको दिए. दैट्स अ सेपरेट मैटर दैट आई विल कलेक्ट फ्रॉम यू लेटर ऑन. फाइन. सो बट मैंने मेरे पास से कुछ अमाउंट आपको दिया, सो दैट इज डेबिट फ्रॉम माय साइड, सो आई कीप इन द डेबिट अकाउंट. Okay, but at the same time, if you consider your example, because I am giving to you, that means you are getting the amount of rupees 50. So whatever be the amount you have earlier, now there is a plus of rupees 50. You have to write the same amount in your credit part. But at the end, if I summarize, then my difference has to be zero. That means अगर मैंने 50 कहीं दिए हैं तो 50 किसी को मिला भी है. ऐसा नहीं कि इन बिटवीन वो कुछ पैसा उसमें से लॉस्ट हो गया या इधर उधर चले गया. राइट? 50 दिया, 50 कहीं पे मैंने किसी को दे दिया, उसके पास उसने एंट्री भी कर ली. दैट्स इट. दैट्स हाउ. So similar tone, you have to apply for this two level system again. So whatever the process we have discussed over here in the last lecture, even in this also I have covered it little bit. All the three process one by one you need to apply. So whenever you see that number of particles are moving from one level to the another level, okay, so whichever is the gaining part, whichever level gains the number of particle, you write with the plus sign. Whichever level loses that number of particles, you write the same thing with the minus sign. Okay, so now let me go, and always there is a trick in that for writing the rates. Always go for the upper level first. Okay, go for the upper level first. So here I have the maximum two energy levels. So first I will write the rates for level number 2, that is dn2 by dt. I will write very first. Okay, let me draw that also. So I will draw over here on the top. These are the two levels I consider. This is level 2, this is level 1. Okay, now all such process, all the three process you apply one by one. So let me apply the first process in which I need to give the energy to this one. Okay, and I consider it is interacting with the level 1. Okay, level 1 particles are getting this energy and reaching to the level number 2. Okay, now what is the rate for level 1? Oh, sorry, what is the rate for this process, this first process, this one? If you remember, in the just last slide we discussed, this is the rate for level, I mean this is the rate for this process, stimulated absorption process. So you write it down. Clear? Why I am writing with the plus sign? So this is with the plus sign. You see, you can write with plus also. Why? Because even though the process is happening from 1 to 2, but ultimately who is in the gain? Level number 2. So that is why this particular process rate I am writing with the plus sign.
Sir, it is also because of the endothermic process, no? Hello. Hello. Sir, you are not audible.
Sir, you are not audible.
Now, is it audible now?
Yes.
Hello?
Yes,
Okay,
sir.
okay.
Yes, sir.
Okay, so look at here. What I'm saying is this first process consider, you apply a signal, okay, number of particles who are in the gaining process, right? Who is the gaining part? I mean, which level is gaining the number of particles? Level number 2.
Yes.
So that rate, absorption rate, which you have written down in the earlier slide, for level 2 you write with the plus sign, which is there, you see with plus I can write W12 N1. Now you consider the remaining two process for the level 2. What will happen next? If this is in excited state, then it will emit via two process, either spontaneous or the stimulated way. If it is spontaneous, then कहाँ से कहाँ आएगा वो? Level 2 to level 1. So for the spontaneous process, you see this is the rate. That rate you have written down over here. But since this process is happening from 2 to 1, so who is the gaining over here? The number of particles are coming to the level number 1. Okay, but this level 2 is losing the number of particles, so this minus sign we are putting over here, because from level 2 number of particles are getting down via the spontaneous process. Similarly, if you consider the stimulated emission process, again in that case also number of particles are getting down to the lower level. That means level 2 is reducing the number of particles, level 1 is the gaining the number of particles. Okay, and that is why the rate for the stimulated emission process, that is W12 N2, we are writing with minus sign. Okay, I have just taken out this W12 with common, N1 minus N2 will be there.
Sir,
Yes.
cannot we apply the logic of endothermic and exothermic, because it is shooting completely, because the system which is absorbing that gives positive sign, and it is releasing energy then negative.
No, what I'm saying is I want to see what is happening in the level 2. Whatever
Okay.
you are saying, that is for the complete system. Okay, but right now I am interested in just only level 2. I don't worry about level 1, what is happening over there. I am not interested, let's say. Okay, so I just need to focus on the level 2 particles, like what are the changes happening in the level 2. So all the three process I consider for level 2, and I see these are the changes which are happening. Clear? Now same thing differently I need to cover for level 1. So whatever the changes you see, all three process again you apply. Let's say first process in which these particles are getting absorbed, reaching to the upper level. So number of particles of level 1 is getting less. Okay, so here the same term which you see W12 N1, here I am writing with negative sign, because this level is losing the number of particles because of first process. Okay, now coming to the second process, let's say spontaneous process is happening, then it is happening from 2 to 1. So via this process level 1 is gaining the particles, so that is why the same rate for spontaneous process we are writing with the plus sign, because now the number of particles are coming to the level 1, that means it is getting increased, plus sign. Similarly, if you consider the stimulated emission process, via which also the particles are coming from level 2 to level 1, so who is gaining? Level 1. So you see this minus and this minus, minus minus plus. So you can write this W12 N2 with plus sign. So I have just taken out minus W12 common, that's why you are getting this minus N2. But otherwise you multiplied with that, it will be plus W12 N2 only. Are you getting this one?
Yes,
That's
sir.
why, yes, that is why I have given you the example of account. Whatever you do some debit in one part, you have to reflect the same thing in the other part. So मैंने ऊपर कहीं डेबिट करवाया, क्रेडिट करवाया, same record I have updated in the lower level also. But at the end, the difference has to be zero. Okay, ऐसा ना हो कि मैंने 5 पार्टिकल तो मेरे ऊपर गए लेकिन आए 4 ही, तो वो पॉसिबल ही नहीं है. So total difference has to be zero every time. So if you do the sum of these two, which is there on the right hand side, you see that if you do the sum of these two, you will always get a zero. Clear? दिख भी रहा है आपके स्क्रीन पे, आप सम करोगे तो आपको जीरो ही मिलना है. एंड इफ यू इंटीग्रेट इट, you know that there is a constant. If you integrate it, that means the sum of n1 plus n2 is equivalent with n or n naught. which is always constant. And that is why I have said you in the earlier example, in the first second process also, maybe in the first lecture, that the number of particles in level 1 and level 2 is always fixed. And we have taken the example of, let's say, 10 number of particles. So 9 will be there in level 1, 1 will be there in upper level or something. You see the earlier lecture recordings, and then you see always the number of particles are fixed in a particular system. So that's what, this is the first proof we have seen over here. Similar proof also we'll see maybe in the next lecture.